Hello and welcome to DataCast Solutions, Statistics and Data Mining 101 using KNIME. In this chapter, we're going to take a look at binning continuous variables. Now, binning of a continuous variable is the process of setting ranges and then treating these ranges as categories. And then further, we have the option of imposing an order upon those categories. And I say we have the option because that may not be necessary or even desirable. We'll talk about that in the next slide. Let's say, as an example, I'm taking the age of my customer and I'm putting them into bins of 0 to 10, 11 to 20, 21 to 30, and so on. And when I'm working on my data analysis, I decide that bins 0 through 10 and 81 through 90 have similar behavior. At least with respect to the problem I'm trying to address. And therefore, I want to group them together. So keeping them in strict order may not necessarily be the choice that's always right for you. And I would say that similarly, when you see classic scorecards built using regression models in like credit risk and marketing applications, they use binning heavily on their continuous variables to set indicator variables. And then they use these variables in very easy to interpret, very easy to understand ways. Now, cardinality reduction is a process essentially of taking categories of nominal or ordinal variables that you've created and combining them into one or more categories to create a new category. Nominal variables with high cardinality are a definite source of problems because if we attempt to map all of their values to indicator variables, we end up with a large number of variables, often 0. On the other hand, if we don't convert them to indicator variables and use them directly as continuous variables, for example, and try to use like a decision tree algorithm, well then we run into the very real problem of overfitting. The process whereby the model simply memorizes the data. It doesn't truly see the patterns in the data. Therefore, whenever it's possible, you should consider reducing the numbers of categories of variables. The objective of binning of the continuous variables and cardinality reduction of the nominal variables are the two most common transformations, and you're going to try and achieve two objectives with it. One is to reduce the complexity of the independent variables. For example, if we took a checking account balance, we might say our model's going to look at a checking account balance in blocks of 500. You keep 0 to $500, 500 to 1,000, and so on. And it very often improves the predictive power of a variable by carefully binning it into groups and categories instead of trying to use it in a continuous form. Binning versus cardinality reduction, they are really essentially the same thing. The only difference is in the fact that when you're binning, the order of the values is taken into account. With cardinality reduction, it is not. The main three questions that are going to guide your understanding of this subject are, what's the maximum number of acceptable categories? How do we reduce the number of categories? And what are the potential issues at deployment time because of that reduction? The answer to the first question is really tough to answer because honestly, it really depends on experience and the nature of the data and your understanding of that data. As a general rule of thumb, for example, if you were to look at marital status, you'd typically break that up into single, married, divorced, separated, and perhaps widowed. And those are the accepted categories. Now, there may be many subcategories within it, but you can choose to bring those together. For example, you might say, I'm going to take divorced and separated and count them as one. Because for my purposes, they're really behaving as the same person. My general rule of thumb would be about a dozen. Let's look at an example of just a case where clearly you're going to have more than you want to deal with sometimes. So I went to the internet and I pulled just a sample of values for marital status. And this is just one website. Of course, there's many different applications use different lookup value sets, but you'll see the values they have here of annulled, divorced, legally separated, married, polygamous, never married, domestic partner, widowed. I've got there are so many different versions of this. We could have persons of the opposite sex living together. They call them Q. I've seen, so many different permutations of it. But what am I trying to study? As I look at all these values, do I expect the behavior to be different? Because as a typical example, in many of the data science applications that I've done, what we're really trying to analyze is a person living alone and a person living with somebody else. And again, whether that be a civil union, a common law marriage, it didn't really matter. I just want to know, are there two people living together acting as one family unit? And that might drive some of the behavior I expect to see out of my model. So when you're doing this type of cardinality reduction, that's what you have to apply to these values. So reducing the number of categories within KNIME is actually, there's two approaches. The first one you can do is to simply filter the rows and say, I don't want them. I can use a rule-based row filter node and say if there are values that represent too small a percentage of the population, I'm going to skip them. That's not going to be the ideal approach. It's very simple, of course, but there are a large number of variables with interacting relationships. You might actually be missing something. So while it's easier, it may not be best. The second approach is to devise a scheme to group them together into smaller sets of new supercategories. And as the example I gave earlier, if we go back to marital status, I might choose to say that you are single, you are married, and you are formally married. And formally married could include widowed, divorced, separated. So I might choose to group them together because in my analysis or the model that I'm trying to build, I'm trying to understand the behavior of people that might behave similarly. So implementing cardinality reduction for me is generally going to be done with a column expression node. I can do it with a rule engine. I want to be able to basically use an if-then-else structure to say if marital status equals civil union, set it to married. If marital status equals married, if marital status, apostle Q, I treat them as one group and I create that new supercategory together. When I'm implementing binning on continuous variables, I'm going to do that on intervals. And each of those intervals is going to be given a unique name, a definition of the range, and open and closed borders, where it starts and where it ends. And then each column is either placed within the bin, a column type, string type columns, or a new binned column. And I'll show you how you can do this. Well, let's just take a look at an example right now. All right, let's do this I'm coming down here into the node repository, and I'm going to pull up a numeric binner. So I'm going to take this node, and I'm going to connect my sample data to it. And now I'm going to define some bins. And I'm going to do these bins I'm going to take the age. So I'm going to start, so it starts from negative infinity to positive infinity. I'm going to go ahead and add a new bin. Okay? And with each one of these bins, when you click on them, you can give them a name. So I can call this first one young. And I'm going to say it starts at negative infinity and it goes to positive infinity, so that's just the one that's there. But I don't want that, so I'm going to add another bin so I can edit this. Now the young bin, I'm going to set this up to be, I'm going to make this screen just a little bigger so we can read this a little better. I'm going to say that I'm going to go up to 21. So basically negative infinity up to 21, I'm calling you young. And then on bin 2, I'm going to go ahead and create a third bin, because I'm going to create bin 2 and say you're middle-aged. And that is somebody who is from 21, and I'm going to say up to 63, the retirement age. And then the last one I'm going to say is an old person, and that is from 63 and beyond. And I'm going to pen this new column and call it age binned. Yep, it's actually that easy. And now I'm going to look at my bin data. And now for each of them, if I move it over to the age column here so you can see them right next to each other, okay, old, young, middle-aged. So I've taken a continuous variable and I've created bins, and I'm going to be able to use this for my models. There are all two special features in KNIME that you can also make use of, extensions to binning. One is equal with binning, and this transforms the variable into ranges that are of fixed width. So, you know, the distance between the start and end of one bin is equal to the start and end distance of another bin. The other is equal height binning. And this basically transformed the variables into n number of bins such that the height of each bin is matched together. That completes this chapter of the class. Feel free to move on to the next chapter.